Let's just dive right in. Picture this for a second. You've got an employee working from a really noisy coffee shop, maybe a vendor logging into your systems from their home office, and a developer accessing critical cloud apps from a completely different continent, right? That's literally the reality of today's distributed workforce. But here's the crazy part. The security architecture protecting all those remote connections, it's probably running on the exact same VPN model built almost 30 years ago. Welcome to this explainer. Today, we're going to break down exactly why that outdated model is falling apart in real time and how organizations are completely overhauling their networks.
So the crucial question we absolutely have to ask ourselves right out of the gate is, can 30-year-old tech secure us today? I mean, it's a massive contradiction when you think about it. We're relying on a security foundation designed back in the 1990s to protect a highly dynamic, cloud-connected, remote workforce in 2026. Spoiler alert, for the vast majority of organizations out there, the answer is a resounding no. Let's look at exactly how we're going to unpack this whole thing.
Here's our roadmap for today. We'll kick things off with the remote work dilemma, cover exactly why traditional VPNs fail, and then enter Zero Trust architecture. After that, we'll dive into modern ZTNA and SASE solutions, outline the key features for your next upgrade, and wrap up with AI and the secure future.
All right, Section 1, the remote work dilemma, the 2026 reality.
You know, what's really fascinating here is the stark contrast between these two environments. Just look at the 1990s data center era. This is the exact environment VPNs were born in. Literally everything lived inside a central physical data center, a fortress basically. Now look at the 2026 cloud and SaaS era. Today your applications are hosted dynamically all over the place, Azure, AWS, or just delivered as software as a service. Traditional VPN architecture simply wasn't designed for a world where the network basically has no physical borders anymore.
Moving into Section 2, why traditional VPNs fail, legacy vulnerabilities.
Let's quickly break down the 5 major vulnerabilities crippling traditional VPNs today. First up, excessive access. A VPN often hands a user the keys to the entire network when, honestly, they just need access to a single app. Second, a massive attack surface. VPN gateways just leave IP addresses and host names hanging out on the public internet. It's basically inviting constant scanning by hackers looking to launch zero-day attacks. Third, slow performance and high latency. Routing all your traffic through one central gateway to reach cloud apps creates a massive bottleneck. It drops connections, frustrates users, it's a mess. Fourth, as we just saw, they just aren't designed for modern cloud environments. And fifth, extremely low visibility. Once a user is inside the network, security teams are virtually blind to risky behavior or compromised devices.
And all of this really stems from the core philosophy of a VPN. In the old model, if a user connected, they were implicitly trusted. But here's the reality check. Trust equals vulnerability. Think about it. If a hacker grabs a stolen credential off the dark web, often for free by the way, they can bypass the VPN entirely. The system just assumes they're a trusted employee, handing them the keys to the kingdom. And what happens next? A devastating ransomware attack. It is a model built on blind trust, and it's a massive, massive weak point.
Which brings us to Section 3, enter Zero Trust architecture. Never trust, verify. So, the fundamental solution to our problem is built on a very simple mantra. Never trust, always verify. Instead of relying on network presence, identity becomes the new security perimeter. Every single access request is verified and then, verified again repeatedly. It grants what we call least privilege access, meaning users get access only to the specific limited applications they actually need, nothing more. It completely replaces that outdated model of blind trust with constant, unwavering vigilance.
Let's get into the tech in Section 4, modern ZTNA and SASE solutions, securing the cloud. Okay, I know, this might look like a giant bowl of cybersecurity alphabet soup right now, but let's break it down together so it's not super overwhelming. At the top, ZTNA, or Zero Trust Network Access. This gives you that precise application-level secure access, effectively hiding your apps from the public internet altogether. Then you've got SSE, Secure Service Edge, which is basically a unified cloud security platform. SSE contains several components you'll see below. SWG for securing web access, CASB for securing cloud environments, and DLP for catching data leaks in real time. And when you combine all this security with networking, you get SASE, Secure Access Service Edge. Think of this table as your ultimate cheat sheet for understanding modern enterprise security architecture. But I know exactly what you might be thinking. Replacing our entire VPN sounds incredibly expensive. Well, let's look at the financial reality. A traditional VPN might seem cheaper up front, sure, but it is absolutely loaded with hidden operational costs. We're talking expensive hardware refreshes, maintaining MPLS lines, crazy complex disaster recovery setups, and just endless day-to-day operations. On the flip side, modern SSE platforms operate on subscription-based pricing. This gives you predictable costs while drastically reducing the operational headache for your IT and security teams.
Section 5. Features for your next upgrade. What to look for. When you're out there evaluating a modern ZTNA solution, there are absolute must-haves across 3 main categories. For security, you absolutely need multi-factor authentication integration, strict device posture checking, endpoint detection and response, and real-time data leakage prevention. Now, operationally, you really want to avoid console fatigue, so a single management console is critical, along with API capabilities for seamless automation and SIEM integration for your SOC teams. And for infrastructure, you need global points of presence, or POPs. This just means a remote user connects to a node that's geographically closest to them, which drastically reduces that latency problem we were talking about earlier. And speaking of infrastructure, 99.999% is an absolutely crucial number. When upgrading, you should demand a 5 nines service level agreement from your vendor. To put that extreme level of rigor into perspective, according to the Uptime Institute, a 99.999% SLA allows for only 5 minutes and 15 seconds of downtime in an entire year. 5 minutes! Combined with automatic failover and multi-region disaster recovery, this guarantees that even if an entire region goes down because of a major event or sanctions, your business just keeps running without a hiccup.
So how does this actually impact day-to-day operations? Let's look at 3 critical industry use cases. Step 1, securing vendor access. Large enterprises outsource constantly, right? ZTNA simplifies and strictly controls exactly what third parties can touch without exposing the whole network. Step 2, ensuring compliance. Because ZTNA operates on least privilege, maintaining strict regulatory compliance and pulling reports becomes infinitely easier. And step 3, protecting the borderless remote workforce. Honestly, it doesn't matter if your user is sitting at home, waiting in an airport, or back at the office, the exact same security policies are maintained flawlessly anywhere in the world.
And finally, Section 6, AI and the Secure Future, the 2026 landscape.
As we look at the modern 2026 security landscape, artificial intelligence is just no longer an optional add-on. It's a core component. Modern platforms are integrating AI co-pilots right now to assist security teams. They use AI for automated threat detection and risk-based access, which actually dynamically adjusts a user's permissions based on their behavior in real time. They even bake security directly into development pipelines with DevSecOps and CI/CD automation. It's a completely active, intelligent defense system, automatically handling the simple issues so your team can focus on the big stuff.
I really want to leave you with this final, somewhat provocative thought. The question isn't if you replace your VPN, but how fast can you modernize? Remote work isn't some temporary trend anymore. It's the permanent reality of modern business. Relying on an architecture from the 1990s simply cannot solve the complex, incredibly high-stakes security challenges of today. The shift to zero-trust, cloud-native, and AI-driven security, it isn't just an IT upgrade, it is a fundamental business imperative. Take a hard look at your current architecture today, because you can be absolutely sure your adversaries already are.